class provides a sorted set of key value pairs like an associative or hashed array. Let's make a working copy of map.cpp, and we'll paste this into our working project and open it up. And we'll compile and run it and walk through what it does. You'll notice on line 3, I'm including the map header, and you notice on line 9, I declare a map object. The object is called strMap, and a map object is declared with two types, the type for the key and the type for the value. In this case, they're both strings, and I'm initializing it with an initializer list. And so the keys and values are like George, father, Ellen, mother, Ruth, daughter, Spike, neighbor's son. And then I declare an iterator of type map string iterator, and we'll be using that iterator throughout. And so this initialization is being done with an initializer list, which is a C++ feature. And without that feature, it's actually pretty complicated to initialize maps, so it's a good thing we have that. The map class has a size method, and you'll notice that the size down here is 4, so there are 4 key value pairs. On line 15, you'll see that we can access an element of our map using the key, using an array index operator, and you see that right here. Or we can use the find method, and you notice that we're accessing this as a pair where the value is second and the key is first. So find returns an iterator to the element that it found, and then we're dereferencing that iterator with the member dereference operator, just like we would a pointer to a structure. So we can iterate the set, and here you see those are the key value pairs that we looked at there in lines 15 and 16, and then iterate the set starts down here, and there's the entire set. And so we're using the iterator that we declared up here in line 11. And we initialize it to begin, and we check that it's not equal to end, and we increment it. And then we dereference it with the standard member dereference operator, just like that. So we can insert an element using insert. And again, I'm using an initializer list. This is the C++ 11 feature. If I wanted to insert element by element, pre-C++ 11, I could use a temporary pair like that, and that works just fine. And after the insert, we look at the size here. And so if I'll scroll down a little bit here, and now the size is 5, and these are the 5 elements. And you'll notice that Luke is right there in the middle because it is sorted by key. If we try to insert a duplicate, come down here, we see that it is still 5. The duplicate wasn't accepted. There is a multi-map type, and if I come up here and I change our map to multi-map, I might as well change the iterator as well. And now you'll notice that it's giving us an error on line 15. That's because this array subscript operator is no longer valid when we change this to multi-map. So I'm just going to comment that line out. And now when I save this and run it, you'll see that if we come down here to where we insert a duplicate, and I'll scroll up here until we see insert a duplicate. Now our size is 6, and we have 2 elements that say Luke is neighbor. And if we come down here to find and erase an element, see, we're going to try and find one called Luke, so it'll find one of the 2 Lukes. And if it finds the element, then the iterator will not be equal to end, and it can go ahead and erase it. And so we'll scroll down here and look at that, find and erase an element. It found it, and it said the size is 5. And if we come back up here and we change this back to map so that we don't have those duplicates anymore, and we compile and run this, then it will find the only one, and the size will be 4 again. If I try to find one that doesn't exist, we save and run that, then it'll say not found, and we still have our 5. So we'll put this back, and we'll save and run, and we're back to having our 4. Now you'll notice that throughout this example, I've been using this iterator and this for loop like this for displaying all the elements in the map. I want to show you one other way, and this only works in C++11, and it uses two features of C++11 that I find very, very useful and convenient. And so I'm just going to type it out here for you, and you'll see how much nicer this looks. And we'll compile and run this. And you see the result is exactly the same there. Now, the two features are, of course, the range-based for loop and the auto keyword. Now, the auto keyword, it's actually a pseudo type. And the way that it works is it creates a variable of the type that is expected in that context. And so whatever the context is, whatever the thing that is being assigned or copy constructed to that variable, it takes that type and it assigns that type to the variable. So we know that the type of the elements in the stir map is this pair of strings. And so I could simply say pair string comma string, and we would have exactly the same result here. So I'll compile and run that, and you see that that works fine. But that's a lot of typing, and it's a lot of stuff to remember, and it's a lot of opportunity for typos. And since this variable is just being used in this very, very small context, it's not even very relevant. And so I can use the auto keyword here, and we're not really losing any clarity because we know what's going on here. And yet it becomes a whole lot easier to read and a whole lot easier to type and a lot less problematic. The other feature for C++11 that I'm using here is the range-based for loop. And so instead of all of this that we've been using over and over, it's just this. So the left side of the colon in the range-based for loop is the thing that the collection is made up of, and the right side is the container itself. And so it just makes for a very clean and clear loop for us to look at our elements with. So the map class provides a sorted set of key value pairs. This is like an associative or hashed array in other languages. This can be very useful in keeping track of key value relationships like usernames or other database keys. Let's